Do not stand at the base of the Hoover Dam until you learn about the silent threat trapped deep inside its concrete. Look, millions of people visit this massive landmark every single year, marveling at a triumph of American grit built right in the middle of the Great Depression. But honestly, in 1936, standard engineering rules said pouring this much concrete in a hot desert canyon was a recipe for total disaster. If workers had just poured the concrete all at once like a normal structure, the internal chemical heat would have reached boiling temperatures. The concrete wouldn't have set properly. It would have cracked, crumbled, and flooded entire regions downstream. Engineers realized they weren't just building a barrier against water. They were battling a massive chemical furnace locked inside the rock. To fix this, experts calculated that letting the dam cool naturally on its own would take over 125 years. Think about that. The center would still be soft and curing well into the 21st century. So they devised a radical solution. They poured the dam as an interlocking grid of giant individual blocks, weaving over 500 miles of metal pipes right through the slurry. They pumped ice-cold water from a massive refrigeration plant directly through the walls to freeze the concrete from the inside out. But the scale was staggering. Navigating the canyon pushed gas transport budgets to the absolute limit, just hauling heavy machinery through triple-digit heat, while workers fought poisonous carbon monoxide fumes trapped in subterranean diversion tunnels. Even after freezing the structure solid, another invisible threat emerged: the alkali-silica reaction. When specific minerals in aggregate rock react with moisture and cement alkali, it forms an expansive gel. That gel absorbs water, expands, and exerts thousands of pounds of pressure per square inch inside the concrete, slowly tearing it apart from the interior. Over time, salt buildup and chemical expansion started forming microscopic fissures deep within the structure. To keep the dam intact, maintenance teams launched a continuous monitoring process, constantly inspecting drainage galleries beneath the lake to ensure internal pressure didn't breach structural limits. They knew that if water pressure broke past those cooling seams, the entire 66 billion pound monolith could split wide open under the weight of Lake Mead. Today, saving the Hoover Dam requires non-stop high-tech vigilance. Engineers now use advanced laser measurement systems and embedded digital sensors to track micro-movements, internal temperature shifts, and seismic stress down to the millimeter every single minute. This live data feed essentially conducts a perpetual megastructure autopsy, predicting structural fatigue long before human eyes can see it. It stands as a monument to human engineering, but it's also a constant reminder that taming nature requires non-stop maintenance. Subscribe to Megastructure Autopsy for more.